Okay, in this video, we're going to introduce what a system of linear equation is, or a linear system, and talk about what makes something a solution to one of those systems. Okay, so a system of linear equations, we might just call it a linear system, is two or more linear equations with the same variables. So system of linear equations, linear system, same thing, two or more equations with the same variables. Okay, we're really just going to focus on two equations. So we're going to have two equations with the same two variables. Most of the time, it's going to be x and y. Sometimes if we're talking about a word problem, maybe we use variables that represent the things that we're missing, but for the most part, it's going to be x and y. So as an example, we have x plus 2y equals 7, 3x minus 2y equals 5. Now, normally, I don't really label them as equation 1 and equation 2, but I'm just showing you that this is the equation 1, and this is the equation 2, two equations, both with x and y. So that is a system, okay? Now, when we did linear equations, our whole big unit on that, okay, the reason there is an x and a y in there is that there's a whole lot of solutions to that linear equation, okay? And when you have all those x's and y's put together in a row, okay, that's what forms that line of the linear equation. When we have a system, specifically, in order to be a solution, it has to be an ordered pair that works in both of them. So there's going to be a lot of ordered pairs that work in our first equation. There's going to be a lot of ordered pairs that work in that second equation. Okay, but for the most part, and we're going to have a couple special cases, but for the most part, there's really only going to be one solution that works in both of them. And when I say it works, when you plug it in, it makes sense. Okay. So we are going to try example 1, which is to see if 3, 2, looking down here, if 3, 2 is a solution to that system, the one that I already talked about above. Okay, and it says plug the x and y coordinates into both equations and make sure it works for both. So I'm just going to rewrite my equations down here because I like to have something to plug into. So x plus 2y equals 7 and 3x minus 2y equals 5. And remember, 3, 2, in that ordered pair, that 3 is the x and 2 is the y. Okay, so in my first equation, instead of x plus 2y, I'm going to make it 3 plus 2 times 2. And I want to know, does that equal 7? I'm going to get fancy on you, and I'm going to put a little question mark on top of that. I'm not going to mark off if you don't do it. But really, you don't know if it's true at this case, and you don't want to say something that's false. So that's kind of like why I'm going to put that question mark there. So it's like, does 3 plus 2 times 2 equal 7? That's what's asking. For my other one, it's going to be 3 times 3 minus 2 times 2. I'm using parentheses for my multiplication. You can use dots, no x's. Okay, but dots or parentheses is fine, but you have to show that multiplication. And same thing, I'm going to say, does that equal 5? And now we do the math and we check. Okay, so 2 times 2 is 4, order of operations. So 2 times 2 is 4, and 3 plus 4 is indeed 7. And we get 7 equals 7, which is a true statement, which means the ordered pair that we plugged in, that 3, 2, does work. And for the other one, 3 times 3 would be 9. 2 times 2 is 4. 9 minus 4 is the 5 that we had on the other side. So plugging in 3, 2 into my second equation also worked because it worked in both. Yes, 3, 2 is a solution. It works in both. It's a solution to the system. Okay, one more example. Actually, I lied, 2 more examples for the next one. Is -5, -1 a solution? This one's a little bit weirder because one of our equations is just y equals -1. We're not going to deal with that very often. I think, though, you may see it on IXL, so I do want to point it out. Really what's happening is it's a horizontal equation, which we don't really need to know right now. But when we go to plug things in here, it's going to be kind of weird to plug it in because there's only one variable there. So we have y equals -1 and 3x plus y equals 16. Okay, for the first one, remember this is x, this is y. For my first equation, I have no x to plug in, so I'm just going to plug in the y, which I have in my ordered pair as -1. So -1 equals -1. That's definitely true. The other one, I do have an X to plug in. Okay, so just to clarify, when I did this question right here, I was taking the -1 from my ordered pair and plugging it into the Y. Okay, for my other one, I do have an X to plug in. We have 3 times -5 plus -1. Does that equal 16? And we get -15 plus -1. Oh, I should probably put my question mark. Does that equal 16? Well, no, -16 equals +16. So that would be a no. So this is not a solution. It worked in one, it did not work in both. So that is not a solution to the system. And my last one, be careful where you're plugging things in on this one because they are a little reversed here. So just make sure X's go with X's and Y's go into Y's. We're checking if -7, 9 is working. So I'm going to plug in 9. Does that equal -10 times -7 minus 5? And I can tell right off the bat, this is way too big, I think. So we get 9 equals +70 minus 5, which would be 65. And really, I don't even need to check the other one because it's not even an answer to that one. So I know it's not going to be a solution. We'll just finish it up though. For this one, we do have 9 equal to negative, ooh, careful, -7. We had a negative from here, but we also plugged in a -7 from our X. And what happens there is that -7 is really a +7. And we get 9 equals 9. So I'm glad we did talk about that because we had to deal with that negative there. So it was a solution to the second one, but not the first one. That ordered pair is not a solution. It's got to work in both. Okay, so once again, checking for a solution for a system, plug in your X and Y in both, make sure it makes sense.